Hi, welcome to Netscribes podcast. I'm your host Siddharth Jaiswal. Today we are going to speak on a very interesting topic, which is automotive sensor cleaning. And with me, I have a very special guest, Miles Flamenbaum. Miles is a prominent leader in the sensor cleaning space and the CEO of Actasys. Sensor cleaning is a very challenging yet a very nascent problem statement that the autonomous vehicle ecosystem is facing. Today, we are going to discuss what exactly is sensor cleaning and why it has become a major concern in the AV universe. The market dynamics, what kind of opportunities and challenges are ahead, and what are the possible solutions, technology, and the roadmap for commercialization. Hello, Miles. Thanks for joining in today.
Thank you. Thank you for having me.
Great. So, Miles, if you can give us a quick snapshot on what sensor cleaning is and what does Actasys do and your journey with Actasys.
Sure. I'd be happy to. At a very high level, there are several industry sectors that are highly dependent on the use of vision sensors. And what I mean by vision sensors are cameras, lidars, infrared, and even to a lesser extent, even radar, which is not vision based, but still certainly a sensor. Um, uh, and they're dependent on those sensors for the success of a variety of products and applications, and ultimately the future capabilities and expansion of their particular sectors. And it's something that I call sensorification, which is not a word in the Oxford English Dictionary, but I'm hoping that it becomes one. But it's descriptive, meaning that there are several sectors that are deploying at a very rapid pace vision sensors for new and advanced capabilities. The issue is that those sensors are sensitive. They're sensitive electronics, and they're prone to function loss and data loss due to a variety of impacts. Those impacts can be weather, so something like rain or mud that gets on the lens of the sensor. It can be heat. They can overheat, and thermal management becomes an issue. And other effects such as vibrations, or other impacts that affect those sensors. Ultimately, what ends up happening is that while those sensors are impacted, they're still delivering data, and that data becomes unreliable. It can't be trusted, and it certainly becomes unreliable for perception. And it's a significant issue where you have these systems that are being deployed, yet there's sort of these real world impacts that affect the data streams. So sensor cleaning is at least from the Actasys perspective, one part of resolving those impacts, mitigating those impacts, or correcting those impacts, so that you're able to get better data through those vision sensors and ultimately be able to trust and rely on that data for perception capabilities.
Interesting. Of late, we've seen a lot of interest coming in from autonomous vehicles. The industry is, as and when they're gradually moving into more sensors coming into the vehicles. We're moving from level 3 to level 4, level 5 autonomy. Uh, Keeping these sensors running has somewhere become a at least a thought in the OEMs, in the supplier ecosystem. So how does Actasys see this space evolving? What is your perspective on the automotive industry?
Yeah, so look, there are a lot of fully autonomous or almost fully autonomous, robo taxis that are in development and testing. There's certainly, I believe it's now 19 vehicle models that have lidars to support level 3 functionality. But as we've seen, the operating domain of these vehicles is limited. Their capabilities are still limited. Some of that limitation is due to the perception stack and the software and the systems that are operating that vehicle. But some of those limitations in the operating domain are due to what I just described, the impacts on the sensor and the inability for those sensors to generate clean data under a wide range of operating conditions. So, the Actasys viewpoint on this is a little bit different than the industry. In that the industry is very focused on cleaning in and of itself, and that's clearly a first step, and that's ultimately the first step that Actasys took, which is at a minimum you need to remove whatever's on the sensor lens to enable data capture. We go a step further in that we sort of break this down into three steps, right? One is detection, and this is a weak point currently in the industry, which is the ability to detect that there is something affecting the sensor, whether it's, as I described before, a physical impact, heat, weather, and then to correct that impact through both sensor cleaning as well as cooling, because again, you have thermal management issues, and also then to report that information out. There's a need amongst a wide range of stakeholders, whether it's the OEM, the driver, or the passengers of the vehicle, service providers, whatever it may be, to understand that there's a sensor fault, to understand under what conditions that occurred, and ultimately to understand if there's a need to actually service those sensors. So we take a much more holistic approach than the industry per se, in that we've understand the scope of the problem to be greater than just the simple removal of something on the lens. I think when you take it down one more level of detail, the how you remove things off the lens starts to also become very important. We've seen several of these robotaxis or several of the tier ones develop cleaning systems that are at the outset initially very effective, but they tend to be based on mechanical systems. So they tend to be based on compressors, or they tend to be based on high pressure, high flow rate liquid washes and sprays, which again are effective, but when you look at transferring these kinds of capabilities into a production vehicle, to the OEMs, it doesn't make sense. These are very large, power-consuming, complex products that are difficult to integrate, and so they don't really meet the OEM requirements. So again, our approach is different from the core of the industry in that we have a different way of cleaning. Our approach to cleaning is air-based, in that we have a unique way of generating an air jet out of an electronically controlled actuator cartridge. So it's a non-mechanical way of generating that air jet. That air jet becomes very capable of clearing things like rain and light dust and whatnot off the lens. But we can also inject into the air jet liquid for cleaning. But because we're leveraging the power and efficiency of that air jet, which consumes very little power, we're able to provide liquid cleaning as part of the process by using much less liquid, much less power. We don't need as big of a pump. It doesn't need to be high flow rate. So we're looking at a different approach, and ultimately, as you go from a single sensor being cleaned to multiple sensors being cleaned on the vehicle, you need an approach that's scalable. And we believe that we have an approach that is not only unique but eminently scalable for the not only the current but future needs of the market space. So I think there's general consensus in the industry that sensor cleaning is a requirement. I think it's just how you go about satisfying those requirements, and we've developed different paths, which we think has a significant set of competitive advantages.
Interesting. As an extension to this, so typically, auto industry is has a legacy mindset, where uh, these are big OEMs who have been working in a certain way. Uh, their mindset uh, is kind of different, but when it comes to sensor cleaning, what we've observed is there are certain OEMs who have been very good at the conventional wiper jet technologies, which they typically use in windshields or headlights. So there are some instances where big tier ones are experimenting with that. However, we somewhere feel that this isn't a sustainable technology going forward. They would using water jets. They might have to replace the petrol tank with a water tank to accommodate this kind of going forward. This might not be a scenario. How, as Actasys and you personally, how do you see how receptive are the conventional players in the auto industry towards new technology? How open are they, and do they even consider sensor cleaning as one of the top priorities in AV development?
Yeah, so that legacy mindset is a really interesting one in this context. The automotive industry is very, very good at uh, producing and installing products and technologies that have been well tested and well accepted. Right, and there are a lot of components on a vehicle that have been, in essence, almost standardized. Yes, they get improved, but those improvements are incremental, and they're features and functions that are generally accepted in the industry. In the sensor cleaning space, that's not the case. First of all, the sensors themselves, the perception stack, the sensors, this is all a very new technology area. It involves both hardware and software, so it already raises the level of complication. And then when you add in a very new approach to enabling those sensors through sensor cleaning, particularly one that is ultimately multidisciplinary, that becomes very difficult for the industry to handle. And so, what we've seen and what we get feedback from in the industry is we need help. We don't necessarily understand all the parameters and inputs and impacts that need to be characterized and well understood to really then develop a set of requirements for sensor cleaning. And they're looking for, if you will, support from a single vendor, right? They're not at the point yet, because it's not sort of established technology or established products, to subdivide the system amongst several vendors, because it is a new area. So that does raise a level of complication. I think that that puts Actasys, at least from our perspective, in a very good position, because we're not just focused on cleaning a lens, but we're focused holistically on enabling sensor operation, and really understanding how those different environmental and operating conditions can affect the sensor function, and ultimately how to mitigate them. And report them as well. So, again, I think, we have an interesting approach. There are several tier ones, and you're right, a lot of them originally had wiper systems groups. So they have a lot of experience spraying liquid onto a glass surface and clearing it off with a wiper. And so they've transitioned these groups to include sensor cleaning, or have developed groups to include sensor cleaning that come out of the wiper systems groups. The limitations that they run into in the first instance are a wiper in and of itself is an object in front of the photonics package, and it's going back and forth. And that can wreak havoc on the data capture. So, universally what we've seen is that everybody recognizes that a wiper is not efficient for certain conditions, and therefore you need air as a cleaning mechanism. A lot of them are dependent on these, again, high flow rate, high pressure liquid pumps to help spray, which does help, again, with certain environmental conditions as well. But you're correct. We've seen estimates that a fully autonomous vehicle with a full sensor package on it could consume, under certain conditions, up to 25 liters of cleaning fluid in a day. And there's no place to put that fluid. You're right. We're going to electric vehicles that fortunately don't have petrol tanks, but you wouldn't want to still have a tank just for a very large and very heavy amount of liquid. So developing a system that is hyper efficient and scalable, and can provide air, provide some liquid cleaning, but in a very controlled fashion, even provide heat for ice and snow. That covers the widest range of environmental conditions for cleaning. And again, to go beyond that, to look also at cooling these instruments, as well as reporting out failures, becomes an even more critical issue. So we see an understanding of the criticality within the industry. They understand that the sensors lose data and they lose reliability. They don't completely understand how. They don't completely understand what is occurring on the surface of the lens and how that impacts the data stream. The question that we get asked most often is, how clean is clean? How do you not only qualify that you need sensor clean, but how do you quantify it? And so we've developed a series of tools and capabilities, born out of initially obscuration detection, to measure it, and to help use that measuring capability both as a trigger for the system, but also to be able to quantify cleaning capability under different conditions. So it does become very complex. The industry recognizes the need, and what's occurring now are early deployments of sensor cleaning technologies, as well as a really heavy effort amongst OEMs and tier ones to do more work in defining their requirements, and therefore defining the technologies that ultimately will satisfy those requirements.
I'm stuck to the statement that you mentioned, how clean is clean. So uh, now, when I look at the technologies out there, so essentially we've uh, narrowed down to four technologies which the industry is experimenting with. One is the conventional Viper jet, the second being use of air in a combination of water, air, and there's another few companies experimenting with ultrasonic in a combination with air. And of course, aerodynamics, that's a pretty expensive affair. So not many people are experimenting with aerodynamics though. But now, how do you see the technology evolving? So you mentioned there is integration of software, hardware, but what would be the core technology for sensor cleaning going forward?
Yeah. So look, we appreciate that there are different avenues that have been pursued. You mentioned some of them. Just some quick comments. In terms of aerodynamics, that's a sort of clever yet obvious approach, right? Which is to design the physical emplacement of the sensors in a way that funnels air towards the surface, which is great when the vehicle's at speed. But if it's probably below 45 kilometers an hour, it's not very effective, if effective at all. So you need a system that can handle 0 to 150 kilometers an hour, right? And that becomes a challenge. We've seen several technologies. I mentioned the wiper in front of the sensor lens, or ultrasonics. The feedback that we've received is that in many cases, either the wiper going back and forth or the rapid vibration of the surface for ultrasonics can again affect the data stream, affect the photonics, and so what we see primarily out of the tier ones, or primarily what the OEMs are looking right now at deployment, tend to be air combined with liquid to satisfy the cleaning requirements. Like I said, I think the natural progression is one that ultimately Actasys is engaged in, which is really following two paths. One is how do you most effectively and efficiently clear off that surface? So, how we generate an air jet is different. How we generate a liquid spray is different. It's much more efficient. It's much more easily integrated into the vehicle. So, that becomes the physical side, if you will, becomes important, because there are a significant series of constraints. Every OEM is moving to an electric platform. You need a system that is not going to be power intensive. It's not going to be weight intensive. So that's the direction of the industry in general. You have to meet those requirements. I think what we'll also see, and where Actasys is already headed, is tools and methodologies and technologies to really understand the conditions, understand how to optimize the system, and that will also include how to optimize sensor selection, sensor location, even the design around the physical installation of the sensor becomes important in the overall effort. So those tools become really important to enabling the OEMs to understand sensor operation under different conditions, optimizing the selection and design, optimizing a sensor cleaning system that goes along with it, and then developing the intelligence around how to monitor the health of these sensors, and how to really ensure that they're operating at an optimal in an optimal way under the widest range of conditions. So it starts to move from a physical challenge, right? You have a surface, it needs to be cleared, and it needs to be installed on a vehicle that has limitations, but you move that very quickly into data and intelligence and analytics. And our approach has been to really focus in on what's occurring on the surface of the lens, under what conditions, why is it occurring, why is it happening, both in real world conditions, so driving in a vehicle, but also be able to simulate that in the lab, and to evaluate the data that comes out of the sensor, and begin to really understand how those two essentially data sets converge and how they diverge, why, and to be able to use an analytical approach to utilize that information to help optimize the system.
Interesting. So, and I just want to step back a bit and understand the commercial roadmap for this technology, as it is very new. Still, the industry is exploring what could be the best and sustainable solution. So, how do you see the commercialization roadmap? Would this tech eventually be an integrated solution by sensor makers, or would OEMs directly choose a sensor cleaning supplier and get the tech, or will it be the more conventional way where sensor cleaning companies coordinate with, partner with tier ones, and then that's the road to commercialization? How do you see the dynamics play around here?
Really good question. So, I think a lot of the activity right now is at the OEM level, with some coordination already with tier ones. But what we've seen is that the need was identified. Um, the innovation groups at the various OEMs and the tier ones as well started to investigate and evaluate different approaches, different technologies, different products. We're now seeing those move beyond the innovation space and into the development and ultimately what we'll get into the commercialization space. So it's moving through the pipeline. I think you'll see at the outset, uh, because it's ultimately the OEM's responsibility to address the problem, is you'll see the first requirements and designs and the commercial thrust come from the OEMs. But ultimately, this is something that will heavily rely on tier ones for integration and production. Um, I think it's an open question as to, in the integration side, how these things get packaged together, whether it will be packaged together with the sensors or separately from the sensors. There are still some issues to be worked out. And we've even seen some of the sensor companies, particularly some of the leading LiDAR companies, start to investigate and at least understand the scope of the need, and understand also uh, what opportunities there are to address that need. So I don't think you'll necessarily see some of the sensor companies developing their own sensor cleaning systems, but I think what we've already experienced, and there'll be more news to come on this, is partnerships where the sensor companies will have some level of preferred provider, where we'll work with the sensor company to do some level of development and optimization so that a more comprehensive package can be presented to the OEM, who will then direct a tier one to develop and integrate it. So, again, as we mentioned before, this is not part of the sort of legacy set of products and capabilities in the industry. It's new. So I think we're going to see a bit of a non-traditional path at first, but ultimately things will settle down where, you'll have tier ones who will get involved in selecting different sensors and different cleaning systems, and integrate those on behalf of an OEM and produce them on behalf of an OEM. But we're not there yet. I think, in the earlier days, again, a lot of this is going to be driven by the OEMs. We have several OEM partners, where we're now at a phase where they're starting to either ask us to bring in a tier one, or to almost dictate. Here's a tier one that we've been working with on this problem. We want you to work with that tier one so that we can develop a commercial solution for production.
Interesting. So my final question would be, now how soon do you see sensor cleaning tech deployed in vehicles on the road? And what happens next once the vehicle is on the road? It took nearly 120 years for us to figure out a service network, troubleshooting codes, who do we go to when there's an issue. Now, the dynamics once the autonomous vehicles come on the roads, how will this impact, and what do you see uh, how things will span out post the vehicles are purchased?
Yeah, so there's a few things. One, we're starting to see cleaning systems get commercialized. Um, they tend at this point to be liquid based and liquid only. So again, as I started off the conversation by talking about the limitation of the operating domains of these new capabilities, these level 3 capabilities, part of the restraint on that domain is the fact that there's not a cleaning system that can address all operating conditions, right? Rain impacts the ability of these sensors to generate clean data. But if you only have a liquid-based cleaning system, spraying water on top of water doesn't really help, right? So, but we're starting to see the early commercialization. Um, you know, uh, we'll see more comprehensive approaches. Again, that will combine liquid with air. You'll see the approach that we'll introduce, which is, it will be liquid and air, also the possibility of heat, as well as all of the sort of software and data and analytics that can go around it. Um, I think ultimately, there's still a lot that the industry is learning. Um, uh, and so once the vehicle is sold, um, you know, there there's a very urgent and open question as to how you service these sensor systems, right? And how you service the sensor cleaning system to go along with it. That's again part of the tool set that we're developing, which is not only do we detect a problem with the sensor, all right, but we can start to get into predictive maintenance, reporting out, sensor health and functionality, understanding if the sensors are properly aligned, if they need to be calibrated, and communicating that information to key stakeholders. So in the first instance, if you're in a car that has, say, level 3 capabilities, you're going to want to know that your optical sensors are not operating properly. You want to know when you can rely on that level 3 system and when it may not be reliable. And that becomes important. But that information is also equally as important to understanding, does that vehicle need to be serviced, right? So as the owner of the vehicle, you want to know either predictively or immediately if there's a malfunction, that there's something critical that needs to be serviced within that sensor system. If you're a service provider, you're going to want the same notification. One of your customers may get an alert. You want to see that alert and say, hey, customer, you need to come in because your sensors aren't functioning properly. They need to be recalibrated or something along those lines. Even fleet managers, right, who now need to understand how that sensor is operating across the fleet, how to schedule maintenance now that you have these new technologies, on the vehicle. That becomes critical. So there's I wouldn't call them necessarily downstream as much as, again, it's more of a holistic approach, which is it's not just clearing a surface, but there's a whole set of issues around sensor function that need to be understood and managed in order to make these systems much more successful, and to make the service and support of those systems as efficient as possible.
Amazing. So, thanks. That was a lovely conversation. I thoroughly enjoyed it. I'm sure the listeners of this podcast will do as well.